Hello! This video tutorial shows how to use the Convolution Reverb effect plugin. This video will present an overview of the Convolution Reverb, instructions on how to modify the impulse response, some guidelines on how to use it as an environmental effect, and how to package the ShareSets in Soundbanks. And finally, guidelines to optimize the impulse responses for best performance. This video assumes you already know how Convolution Reverb works and how impulse responses are recorded and processed so they can be used by the plugin. Convolution Reverb is a technology that generates reverberation by reproducing the acoustic characteristics of a room from pre-recorded samples. These recorded samples are called impulse responses. As with the other effects in Wwise, the Convolution Reverb has to be inserted on an object, most likely a bus, or used as an environmental effect. The Convolution Reverb comes with a series of impulse responses you'll find in the ShareSets tab in the Effects section under the Factory Convolution Reverb Effects work unit. If you don't see the work unit, it's probably because your project was created with a version prior to Wwise 2010.2. To get this work unit in your project, simply create a new project, go in the Effects folder, and copy the Factory Convolution Reverb Effects work unit to the Effect folder of your actual project. You can also create ShareSets with your own impulse responses. If you decide to go this route, you can import them as long as they are in PCM format, 16 or 24-bit, and up to 96 kHz. Once you have selected a factory ShareSet or you have imported an impulse response, a series of properties becomes available, allowing you to modify the impulse response. Let's have a look at these properties now. In the Reverb section, you will notice that there are two types that can be selected: reverb or filter. For all reverberation purposes, reverb should be used. The filter type should be used to apply a complex frequency response to all input channels. Brick wall filtering and guitar cabinet simulations are examples of how the filter mode can be used. The IR stretch property applies a pitch effect through resampling. This will ultimately affect the duration of the impulse response and can be used to simulate smaller or larger spaces. Setting the IR stretch to below 100 will speed up the impulse response with higher resonance frequencies, which is typical of smaller spaces. Setting the property to above 100 will slow down the impulse response with lower resonance frequencies, which is typical of larger spaces. Let's listen to three different examples where the IR stretch property is set at 100, 50, and 200. It's a good idea to adjust this property first, since it modifies the impulse response duration and can drastically modify the tonal characteristics of the room. If we look at the graph below, you can see a graphical representation of your original impulse response. Note that any modifications to the impulse response properties will not affect the graphical display because it shows the original and not the modified impulse response. When modifying the begin cursor, it is a good idea to zoom in to get a magnified view of the first samples of the impulse response in the graph. This will allow you to remove any unnecessary silence. Be careful when removing samples at the beginning, since they can represent the pre-delay of the reverb. If this is the case, you should remove these samples and compensate by adding this time in the pre-delay property. In this example, 30 milliseconds of the pre-delay time has been removed. To keep the same pre-delay time, we will add it to the pre-delay property. This way, we preserve the character of the room while saving runtime memory and CPU resources. It is also possible to shape the impulse response in the graph by using a volume and low-pass filter curve. This will help customize the characteristics of the room. When we select the volume curve, the dB scale will be shown on the y-axis. If we select the low-pass filter curve, the frequency scale will be shown on the y-axis. If you create attenuation curves, there is a good chance that they will also change the RT60 value. This may allow you to reduce the impulse response duration, which will help to further reduce resource usage at runtime. The most significant part of the signal for the convolution reverb operates inside the RT60 range. When adjusting the end cursor, it's often a good idea to look at the RT60 value indicated in the impulse response information section. In this example, RT60 indicates 0.8 seconds. This value is a good starting point to set the end cursor. You can then use trial and error to reduce the end time even further to save additional resources. Listen to the end of the reverb tail to make sure it has not been truncated. All the other properties in the input, reverb, and output levels group boxes only affect the mixing volume and not the impulse response. Convolution reverb, applied as an environmental effect, is perfect for simulating indoor and outdoor spaces. The convolution reverb works like the other environmental effects, except for the impulse responses, which have to be packaged in the Soundbanks and loaded at runtime when the effect is needed. Since the impulse response can represent a fair amount of memory, it is a good idea to create a single Soundbank for each impulse response. This guarantees that you will never need more than what is actually needed at any given moment. To package an impulse response in a Soundbank, switch to the Soundbanks layout and create a new Soundbank for your effect. Locate the effect you want to package and then drag it to your newly created Soundbank. After generating the bank, you'll notice in the Soundbank Manager that the bank type is tagged as Plugin Media. Also note that the event checkbox is disabled on the Add tab of the Soundbank editor. This is because a convolution reverb ShareSet only contains structures and media. At runtime, the programmer will have to load the Soundbank containing the impulse response into memory in order to process the effect. The convolution reverb plugin can be quite costly in terms of memory and CPU at runtime. Basically, the performance of the convolution reverb is directly related to the duration of the impulse response. Let's take a closer look using this graph. If you double the duration of the reverb, it will take approximately twice the runtime memory and CPU usage. This reveals how important it is to be sure the end cursor is as close to the begin cursor as possible. If performance becomes an issue, you can try reducing the end cursor to a point where there is a cut in the tail. Although the gated tail can be heard when listening to the sound in isolation, it will probably never be noticed once in-game with many sounds playing simultaneously. The factory convolution reverb ShareSets shipped with Wwise are generally set to be as short as possible. You can use these ShareSets as a starting point, and then reduce the impulse response duration for more performance, or augment it if you can hear the gated tails within your game. That's it! You now know how to use the convolution reverb effect. For further information about the plugin, refer to the Wwise Convolution Reverb plugin section of the help.